In this video, I have this half-wave rectifier circuit. I have a 5-volt peak signal of a sinusoidal wave at the input. I have a 1.5 volt DC source in series with a diode. And I'm using the 1N4007 diode. Now I want you to notice how I have the 1.5 volt DC source and the diode in the circuit. I have the positive side of the DC source and it's connected to the anode of the diode. And the negative side of the DC source goes back to the input. On the output, I've got a 1K ohm resistor. Now, I have Vout1 and Vout2. Now, Vout2 is the output. I have my 5 volt peak. At the output, you'll see a waveform like this. And you also have a waveform beneath this one. This waveform is what the diode is doing. Now, when the diode is conducting and you see this straight line, this is what the output is doing. Now, when the diode is not conducting and going into reverse bias, you have 0 volts at the output. And again, right here, this straight line means that the diode is conducting, and you have this waveform at the output. And over here, this is where the diode is not conducting, and again, you have 0 volts at the output. Now, I've got 0.598 volts across this diode. Now, how do I know that? I put the diode in series with the 1K ohm resistor, in series with a 1.5 volt voltage source. I put my voltmeter across the diode, and the voltmeter gave me a voltage of 0.598 volts. And then I put my voltmeter across the resistor, and my voltmeter gave me a reading of 0.889 volts. Now I'm going to talk about output number 2. A correction, output number 1. At output number 1, this is when the diode is in reverse bias. When the diode is conducting, the voltage is a plus 0.598 volts. When it begins to go into reverse bias, that voltage starts when the negative input goes to minus 0.889 volts. And that's the reverse bias and the open circuit. Now let's calculate the V out on the output. V out equals the 5 volts peak in plus the 1.5 volt DC minus 0.598 volts. And that will give you a V out of 5.902 volts. Okay, now back to output number 1. Now when you add this voltage to this voltage plus this voltage equals that voltage. So you go 0, VDC equals 0.598 volts minus 0.889 volts. And that will give you 1.487 volts, which is approximately what this is. Now, why are these voltages so different? Why are they not exactly the same? Because this is actually a live circuit, and we really don't live in a perfect world. But the idea is that when you add these two voltages up, the idea is that you get this voltage right here, this 1.5 volts DC. The minus 0.889 volts is when the negative input begins to throw the diode into reverse bias. And you essentially have an open circuit across it when the diode is in reverse bias. And this brings me to the end of the video. Like and share the video, and subscribe. Thanks for your attention.